Hi there. So here we are going to talk about how to solve a coding question. One mistake a lot of people do when preparing for technical interviews is trying to solve as many LeetCode problems as possible and memorizing the answers. This approach is wrong. In an interview, you will likely face a problem you haven't seen before. What matters is not remembering the solutions, but recognizing patterns and applying them. So a good structure is first to start with clarifying the problem. Spend at least 5 minutes asking questions before jumping into a solution and make sure you fully understand the requirements and constraints. For example, is the array sorted? Can it contain duplicates? What kind of inputs should you expect? Also, check for edge cases. Can the input be empty? Can it contain only one element? Taking the time to clarify the problem prevents wrong assumptions and show that your thinking is structured. So write down the question, the constraints, the input, and the output. Okay, so let me give you a concrete example. I'm going to ask you to find two numbers in an array for which the sum is equal to the target. And I want you to return their indexes. So I will give you this array with the target number, and you should return this. That's all the interviewer is going to ask you. You have to clarify the problem. So before coding, ask, are there always exactly two numbers? So let's assume yes. All right. Can numbers repeat? So as an interviewer, I may say, no, there is no duplicate. No duplicate. Really write down everything. This way you can remember them when you actually resolve the problem. Can there be a negative number? Yes, there could be negative numbers. Should I return indexes or values? So indexes is here, but it's still good sometimes to clarify the problem or the output. Okay, this here really avoids wrong assumptions. Once you've done that, you should first give the brute force solution. This is the most straightforward way to solve the problem, even if it's not optimal. If nothing obvious comes to your mind, walk through a simple example, step by step. Once you have a basic solution, explain its time and space complexity. So my first idea here would be to try every pair of numbers and then check if they sum to the target. So typically I would have 2 for loops where I will sum every number together. Well, if I do that, the time complexity will be O of n square. And the space will be O of 1 because we are not using any additional space for this solution. Okay, so after giving the brute force solution, you can start thinking about the optimization. Think about what you want to improve. Is it the time complexity or the space complexity? Or maybe both sometimes. Ask clarifying questions if needed, such as whether you're allowed to use additional memory. This is where pattern recognition becomes important. Many problems can be solved using common techniques like hashing to pointers or recursion. A helpful resource for learning these patterns is Cracking the Coding Interview from Gail Lachman McDowell. which introduces very helpful concepts like problem solving, triggers, and patterns. You should really get this book. If you get stuck, explain your thinking out loud. Break the problem down in plain English. Then test ideas on examples and remember the edge cases. This shows the interviewer how you approach challenges, even when the solution doesn't come instantly. Once you reach a solution, clearly state the final complexity and confirm with the interviewer before writing the code. Only then you can start implementing your solution carefully, test your code using the edge cases first, and then try with a larger example to validate your logic. This helps you catch mistakes early and show that you have a strong problem solving. So let's work on our optimization. The first thing to see that we can see is that our space is constant. So there is nothing to really optimize here. On the other hand, the time complexity is O of n squared. And we might be able to do this in O of n by looking at every element. I think the best way to do that is maybe to use a map. And in this map, we will keep the current element, every element of our array and its indexes. And when we go through the array, we will check if the complement of the current number is in the map. So what does that mean? Is that we will have our map here, and in the map, so we'll start with 2, obviously, 2 and its index, which is 0. And then we will see 7, the complement of 7, so 9, so the target minus 7, the current index here is equal to 2. Is 2 in our map? Yes, so we'll return the index of 2, but also the current index, which will be 1. Now the question, this is too easy. Let's make it a little bit more complicated. If 7 was here, what does this mean? So our map is empty. We start with 2. There is nothing to compare with because the map is empty. We will add 2. And once again, 0. Then next, we have 14. We'll do 9 minus 14, which is 5. Is 5 in our map? No, so we will add 14 and 1. Then we continue. We will have 9 minus 11. It was actually minus 5, not 5 here. We will have minus 2. Is minus 2 in our array, in our map? No, so we'll add 11 and 2. Going too fast, not good. And finally, we will have 7, and here we will have 2. Is 2 in our map? Yes, so we'll write down the index, which is 0, and 3, 0 and 3 in this case. Okay, we have this. So let's write down the pseudocode. So once again, the idea is to have a map. We'll start with creating a map, which will be at the beginning empty. And then we will loop through the nums. For every number, we will check the complement. So we'll have the target minus the current number. And we will check if the complement is in the map. If yes, we will return a new array of the complement. I mean, it's not the complement, it's going to return the index here. And the num, so the index of num. And if not, so we will just add the number and index, the current index in the map. Okay. So this is the pseudocode. This is really in plain English. The first thing before going to the coding phase, just double checking that this makes sense. There is no bug, and I haven't like mixed the number and the index, which is very easy to happen. So once again, I will go through my algo, my example. So I'm going to create a map. I will look through nums, and then I will create the complement. So the target 9 minus the current element. So we'll start with 2, which I'm going to do it just under. So at the beginning is empty, and then I have the complement. So we start, the map is empty, we look through nums. So we'll calculate the complement 9 minus 2, which is 7. Is 7 in the map? No, because the map is empty. So I'm going to add the current num, which is 2, and its index, which is 0. Okay, so next, looping complement of target 9 minus 14 will be minus 5. And then is it in the map? No, so I'm going to add the current num, which is 14, and the current index, which is 1. Next, we have 11. 9 minus 11, which is minus 2. Is minus 2 in the map? No, so I'm going to add the current element, which is 11, and 2. And finally, last element is 7, so 9 minus 7 is equal to 2. Is 2 in the map? Yes. So this time we will return the index and the index of num, which is 3. And this is correct. This is what we are looking for. So really important to go through this. Once you verified your pseudocode, you can code, and it's very easy, because you already wrote almost everything here. So you just have to like, oops. So you would just literally have to create your function. I'm going to code in Python, but I will do some and have my nums and target. I'm going to create my map, and I'm not going to call it map. It has to make sense. I'm going to call it scene. Is it an element that we've seen? And then I'm going to loop through I and num, because we need our indexes. And we use enumerate nums, and so then we will compute the complement, just as before, of the target minus the current number. And then we'll check if the complement is in the map, is in scene. Then we will return a new array of the index of the complement and the current index. It's not, finally here, we will add inside of our map the current number and its index. And that's it. Typically, this is what I'm doing. I'm adding a map here. I'm looking through the nums. I compute the complement, and I check if the complement is equal. If the complement is in the map, I return the index of the complement and the current index. If not, I add the current number and its index. And that's it. This is the code. And because I've checked it before, I almost do not have to check other things than the syntax. The new time complexity is O of n. And the space complexity is also O of n because I'm using this map. So it is much better than it was before.